Alright, so for this graph, it looks like how many vertical asymptotes do we have? Looks like?
2.
Looks like we have
2 vertical, 1 horizontal.
vertical right here?
Yeah, 2 vertical.
2 vertical looks like, right?
Yeah.
So we have 2 vertical.
We have 1 horizontal.
Hold on. Let's do one at a time. Okay, vertical. And then one of them is at where? -2.
And 5.
Okay, so hold on. We also need to put because as x is approaching to -2, right? It goes to both positive. Do you see that positive infinity? I think this is the best answer, right? All right, make sure you check to see what I'm doing.
Yeah.
I think there might be 3, right? I think you're right. Okay, and then another vertical at
5.
5. I think 5 might be the best one. Does everyone see that 5 might be the best?
Yeah.
All right, I'm hoping this is correct. All right, and then as you approach to 5, oops, I made a mistake. It shouldn't be negative infinity. It should be positive infinity. Does everyone see why this is positive infinity? Because you're going up and up, right? Looks like there is a horizontal asymptote. Horizontal asymptote is right here. Do you see it? At 2. So we do have one horizontal asymptote at 2. Okay, because we're going to the right, right? We're moving to the right. As we're going to the right, looks like it's getting closer to 2. All right, so I'll give you time to kind of look at what we have, because it looks like there's a vertical asymptote here, here, and there. So we should just add 3. And then hopefully I don't have to record this again. Yes. All right, we got it. All right, don't be laughing because it will be recorded. Let's not tell anyone. All right. Okay, so we'll also look at limits to infinity. All right. So for something like this, it is very hard to see. All right. So what you need to do is you need to use your graphing calculator. Go ahead and use your graphing calculator to put this in. We practice a little bit with your graphing calculator. And then what does it mean by this right here? What does it mean by this? Which direction are we going? When it says limit as x is approaching to infinity, which direction is that?
Right.
To the right. As you go to the right, tell me what happens to your function.
Approaches 0.
It does not approach to 0. You need to look at your graph. That's why I spent 15 minutes with you in the beginning so that you understand how to graph this. You can zoom out if you need to, or you can zoom in. All right, whatever you need to do. All right, can someone tell me what happens as we go to the right? What happens to the function? Let me see your graph.
I don't think I did it correctly.
Okay, so your graph should look like something like this and like that. Does it look like that here? How many of you guys got this? Okay. So if you have something like this, as we go to the right, what happens to your function? It goes up, doesn't it go up? As you go to the right, it's going up higher and higher.
Yeah.
So it is to the positive infinity, isn't it? So what does it say? If your limit is infinity or infinite, which is infinity, then it does not exist right here. Alright, so we're going to put alright, so look at your graph right here. Well, they don't show you the graph, but so they're showing you the shortcut. They're saying that, remember I told you in the beginning of the class, you can use your graphing calculator, but there's got to be a shortcut to this algebraically.
Yeah.
So they're showing you the shortcut algebraically. They're saying you can ignore everything else and you just need to concentrate on which one. Yeah, the highest power. And you just need to reduce this one right here. That's all you need to do. So when you reduce, isn't that just 40 over 9 and then basically x? So when you have x, this is a line. Does everyone see that y is equal to x is a line, like that. So it's going to go up higher and higher. That's what it's saying. Or you can plug in infinity into this x. It would be infinity times anything is infinity. Therefore, your limit is infinity. Basically, that's what they're trying to tell you right here. Okay? But you can use your graphing calculator for this. All right. So let's go back. All right, same thing with this. Let's go ahead and practice graphing this. Go ahead and take your graphing calculator and graph this thing. And again, we're looking at as x goes to positive infinity, that means what? We're looking at going to the right. All right, you can see your graph. It's e to the power of 1 over x, not e.
Oh, I did not. Actual. In this case, and then right there,
All right, check. Okay, does it look somewhat like this?
yeah.
Does it look somewhat like that? Okay, how many of you guys got that? Okay, so anybody have an idea? As we go to the right, what happens to your function? Where does it go to?
Some number.
Yeah, some number. Yeah, you have to guess that number. What number? What do you think? Yeah, it looks like if you happen to guess this number, what number do you think you have right here? If you happen to take a guess.
3.
3. Okay, how many of you guys see that in your graph? Only about 6 people? Oh, no, you need to graph this. And then you need to see it, guys. Alright? Listen, there's a algebra way to solve this problem, but I'm telling you, using your graphing calculator is the easiest way. You just need to graph it and see it. Okay, so if I happen to guess, I'll guess about 3. And there it is, okay? And this is more of a shortcut algebraic way, all right? All right, now if you don't have a graphing calculator at home, what should you use? Desmos. Okay, I'm going to skip the next one. We're going to go to the piecewise function. All right, you got to learn how to graph these functions. All right, so you need to graph this one. But you should know this already. Anybody have an idea what type of graph we're going to get with this? It's a line. It's linear. It is a line. All right, so go ahead and graph this with your graphing calculator. Okay, so you get a line like this. Don't you get a line like that? Okay, I'm sure it's a different color, but mine is purple. How many of you guys get something like that? Raise your hand. Guys, these are just graphing calculator. You got to know how to do it, okay? You're just graphing. Do I take the whole thing or do I need to erase part of it? You need to erase part of it, right? So where do I erase from? Anybody know where I need to erase this from? Like this will tell you right here. Yeah, so you need to find -4 down here. And then you put a big open circle there. It should be an open circle. Which part do you erase? Yeah, you need to erase all of this stuff right here. You need to erase that. Does that make sense? Alright, so I'm going to erase all this.
Okay, so see when it's asking for numbers greater than -4, you erase the left side.
Yeah, because remember, these numbers right here, when they say greater than, we're looking at,
Oh, that's our range. That's
Yeah.
range. Oh, okay, got it.
not range, that's your domain.
Yeah, my bad.
Okay. Okay, but how do I know that this was open? Can someone tell me why this is open? Yeah, it says greater than. Remember, strictly greater than means open, right? Okay, so what happens down, let me change color now. Should I change it to green? Again, my computer is kind of slow, but do you see this? So this is closed because it's less than or equal to where we're looking at on the left side. So what is this? Go ahead and graph this. You can graph both of them on the same screen. Okay, how's it going? Do you see both of them on your screen?
Yeah.
You see your graph? This one you need to use a negative symbol, not subtraction. Okay, so does it look like your parabola is somewhat like this? Like that? Do you get something like that? So all of these part right here you have to erase. Does that make sense? All of those parts. So you're only keeping this part right here and the purple part. And do you see this open circle? You need to fill in that circle with closed circle now. You gotta know how to do this. Piecewise function is important. Okay, you gotta know how to figure out your piecewise function. You're gonna get a whole bunch of these things. How many of you guys follow what I just did? About a handful. Okay, a little bit more. Okay, so you want to get to here. Let me change color. You want to get to here. It says limit as x is approaching to -4 here. What is your limit? Anybody have an idea what your limit might be? Remember, limit is your y function value right here. Anybody have an idea?
Like 6.
Okay, I would agree. All right, I think I would say it will be +6, isn't it?
Yeah.
All right, so let's go ahead and put +6. Submit your answer. Let me clear this because this is all messy. There you go. All right, so you can tell that a lot of it is with your graphing calculator. The last part of your homework assignment, it is using algebraic skills, factoring. Let's see if you can figure that out on your own, okay? If you need some help, raise your hand, and I'll walk around and help you. All right, so go ahead and work on your delta math. Let me stop recording this.